Okay, so to start this one out, we want to draw the diagram, okay? And so we've got 25 kilometers at 20 degrees north of west. So when I want to draw that vector, I know that west is my reference direction. Okay, so what I do is I just draw a line that goes west. Okay, and then I go 20 degrees north of that. And I did a terrible job of picking where that should go. Okay, so there's my first vector, 25 kilometers at 20 degrees north of west. Right? My second vector is 10 kilometers due south. So we draw these things tail to head. So I go to the head of the first one, okay, and I put the tail of the next one on there. Right? And how long do you suppose this side is? This is where, like, sometimes the scale gets tricky. Okay, like 10 kilometers long, if I'm not careful, okay, because it's going to be close. It might be a little bit below, it might be a little bit above. Okay, not really 100% sure on that. I know if this was a 30-degree angle, this side would be 12.5. Okay, but it's a 20-degree angle, so it's going to be like really close. Okay, and we can see from the answer here that it is really, really close. All right, so here's what I do sometimes. If I'm not sure how long or where I should end that line, I actually just start my trig before. Okay? And I say, all right, here's the x component of the 25, here's the y component of the 25, and I calculate them right off. Okay, so x is the adjacent side, so what trig function should I use there? Cos, yeah, I'm looking for the adjacent side, I have the hypotenuse, right? So I'm going to go cos of 20 degrees times 25, the hypotenuse. So this side here is 23.492 kilometers west. Okay, and the y component is the opposite side. So what trig function do I use to find that? Sine, yeah. So I'm going to go sine of 20 times 25. All right, so that's going to be 8.551 kilometers south. Now, that's the side that helps me. I now know that this green line that I labeled as green y is only 8.51, or sorry, that's supposed to be north. Is only 8.551 kilometers long, and the line I'm about to draw is 10. Okay, so now I know this line's got to go just past that one. Everyone follow what I did there? Okay. If I'm ever unsure, and this is a case where I could be unsure even if I'm being careful about my scale, okay, I just double check it. I actually do the calculation first so I know for sure. All right, so that black arrow is 10 kilometers and it's south. All right. So now, where is a line that can be drawn that's going to represent the total displacement of this truck?
From the end of the black line to the start of the green line?
Right, but actually in reverse, because this is where I started, right? Yeah, okay, but you're absolutely right. I want to connect those 2 points, okay? But I want to draw the arrow. Whoop. Okay, that line there, that arrow would represent the total displacement. That's the total change in position of that truck. Okay. Now, does it also have a right angle triangle? Yeah. It does. And I can draw it one of 2 ways. Okay? I can draw it like this, or I can draw it underneath. It makes no difference which way. Right? All right, so that triangle also has an X and a Y, or a horizontal and a vertical component. It's the resultant, okay, and it represents the displacement. All right, so if I'm going to get red x and red y, what else do I need to do?
Well, to find red y, you can just do 10 minus 8.55.
Exactly, okay? So if I'm looking at my 10-kilometer long line here, okay, does it ever go east or west? Okay, it doesn't have an x component, it's vertical, right? And as Tony pointed out, its y component is 10 kilometers south. So to find red y, I would take black y, 10 kilometers south, and I would subtract 8.551 kilometers north. Right? That's going to leave me with my overall y component, or red y. Now, should I keep all the decimals when I do that? Definitely, because I'm going to do Pythagorean theorem with that number, and that means I'm going to square it, and if I've cut it off, rounded it off, I'm not going to get an accurate answer. Okay, so I'm going to take 10, and I'm going to subtract that number right there, and I'm going to get 1.449 kilometers south. Okay, so that's how long red y is, 1.449 kilometers south. How do I get red x?
Find green x.
Yeah, it's equal to green x. Remember, my other vector didn't go west or east. So the only time I went west or east was when I went 23.492 kilometers west in the first vector. Okay? And even on my diagram, it's pretty obvious that red x and green x are equal, yeah, the same. Okay, so that's kind of the importance of doing a diagram. Sometimes it saves you work and confusion, if you draw it right. Okay, at this point, do I know both sides of my resultance triangle? So what can I do now? I can do Pythagorean theorem, right? Which will get me the magnitude of the displacement. Right, so that's going to mean 23.492 squared, but I'm going to keep all the decimals because they're still in my calculator, okay, plus 1.449 squared. Also, I'm keeping all the decimals in my calculator. I'm just not writing them all down here. All right, so that one squared plus that one squared. All right, so my overall displacement is 23.537 kilometers. Okay. What else do I need to find? I need to find the angle, because displacement's a vector quantity. So, which angle do I want to find? This one or this one? Yeah, this one. Remember, if you're ever uncertain, draw a circle around your starting point. Wherever that circle goes through your resultance triangle, that's the angle you want to find. It becomes the angle arc for the angle you want, because it points from beginning to end, and that's the direction you would travel. Okay, so I'm going to find theta. I can use any trig function I want at this point, can I? Right? I calculated everything about that triangle, so I can use sine, tan, or cos to get this angle. But tan is my favorite, so I use it. Okay, so 10 to the minus 1 of, for me, y over x. So 1.449 divided by 23.492. And so opposite over adjacent. And again, I'm going to keep all those decimals. So second tan of that number there divided by. All right, so I'm getting 3.53 degrees. And for me, that's going to be south of west. All right, how many significant digits did my answer have? Just 2. All right, so now I gotta look at those numbers I calculated. It's gonna be 24 kilometers at 3.5 degrees south of west, okay? Or if I had done this the other way, drawn the triangle the other way, right, I would have had 80, yeah, would have been 87 degrees west of south because, oh no, it would have rounded up. Sorry, it would have been 86. Okay, does that look a little bit weird that one of those has a decimal and the other doesn't? It looks a little bit weird, but it's the right number of significant digits. They both have 2. Okay, just kind of worked out that way. All right, everybody okay with what we did there? That's the level of difficulty I would put on the unit exam. Okay, one straight one and one angled one. Right? We're gonna do harder ones than that in class for sure. But when it comes to the unit exam, I wanna save a little bit of time and you can still show me you know how to do this with one like this. So,
When you're finding the angle over there, when you find the bigger one or the smaller one?
it doesn't make any difference. You find whichever one is inside the triangle you drew. Okay, so yes, I found this angle here because it was the one that was pointing from start to finish for me. But had I drawn the triangle this way, I would have found this angle then.
Oh,
And it would have been fine. They're the same direction. They just reference a different compass direction. Yeah. Okay, that ringing a bell? All right, so the steps are, you gotta draw the diagram. You got to find your x and y components using trigonometry. Add your x's together, add your y's together to get your resultants triangle. And then from there you can do Pythagoras, trig, and you're done. Okay? The good news is it's always the same steps. Okay? All of these questions work the same, fundamentally at least. Oh, that's an easy one. We won't do that. We need something harder. Okay, here's a boat question. You guys remember the boat questions? Do we need to go over the boat questions before we, or do you guys want to try it first? I'm gonna let you try it first. I think that's a good idea. So here's my river, okay? And my rowing speed is 4 meters per second, and it says I'm rowing directly north across the river. Okay, so that's going to be 4.0 meters per second, which is like beyond Olympian rowing speed. Okay, it's crazy. And we know that the current is moving east at 1.6 meters per second. Okay, what is our resultant velocity? So our resultant velocity is going to be that line right there. Okay, connects the beginning to the end, right? That's my result. So I can calculate that simply by doing Pythagorean theorem and then a quick trig calculation in order to get the angle. Okay, so our resultant velocity is going to be the square root of 1.6 squared plus 4 squared, okay, which is going to give us 4.3 meters per second. Everybody all right with that? Okay, and then my angle is going to be tan to the minus 1 of the opposite side, 1.6, divided by the adjacent side, 4. Okay, and that's going to give me 22 degrees east of north. Okay, so that's my resultant velocity. Now, it tells me that it takes me 3.5 minutes to row across the river. Okay, so it's telling me that the time is 3.5 minutes. What do I probably want that to be in? Seconds. Okay, so we'll just quickly do that. All right, so it takes me 210 seconds to cross the river. The entire time I'm rowing across the river, what am I also doing? Getting pushed downstream by the current. 1.6 meters every second. Yes, Follow my logic here? Okay, unlike the displacement vectors where it's like this one happened and then this one happened and then this one happened, velocity vectors can happen concurrently. That means they happen at exactly the same time. So while I'm rowing, I'm also floating down the river. Okay? I don't end up straight across the river. Okay? The only way I would end up straight across the river from here is if I rowed this way and let the current push me back to straight across. Follow my logic on that? Okay? So if I know that I'm going downstream at 1.6 meters per second, and I do that for 210 seconds, can I figure out how far downstream I go? It's just a V equals D over T calculation. Okay, so 210 times 1.6 should give me 336 meters, although it should be 3.4 times 10 to the 2 meters, if we're doing the right number of significant digits there. Okay? Is everyone all right with that idea? Okay. Boat questions, they seem complex, but they're always perpendicular. Okay? Even if I have to row slightly into the current, it pushes me back to straight across. I always get a right angle triangle out of it. Any questions on that? All right. Okay, so this would be two angled vectors. Right? So drawing the diagram is super important. So I'm going to give you a few minutes to copy this one down and draw the diagram, and then I'll draw the diagram. You can check yours against that one, and then you guys can move on to the calculations and we'll see how we do. All right, so let's look at this one here. So we got 10 kilometers south, 8.5 degrees south of west, and then we got another one that's also south of west, but at a different angle. So I'm going to start over here in the northeast quadrant, so I have room to draw the whole diagram. Okay, so we've got 10 kilometers at 8.5 degrees south of west. So I'm going to draw a reference line that's west. Okay, I'm going to have a very narrow triangle because my angle is only 8.5 degrees. So this is 10 kilometers. And that's 8.5 degrees. This would be its x, or horizontal component, and this would be its y, vertical component, or west and south components. Then it goes 7.5 kilometers at 30.5 degrees south of west. So again, I'm going to draw another reference line that's west. This time I'm going to take a bigger angle out of it. Okay, something like that. So that'll be 30.5. This will be 7.5 kilometers. This will be x, and this will be y. Okay, so where do I draw a line representing my total displacement? Okay.
From the tail of the blue line to the head of the green line.
Exactly. From the beginning, the tail of the blue line, to the head of the green line, that would represent my total displacement. Now, for me, I don't like to draw my triangle over top of the lines I already have. I find that it starts to get crowded and busy looking, but if you want to do that, you totally can. Sometimes people like to see it because they can totally see how the x's and y's go together that way. Okay? For me, I am going, well actually because of the answer I have on there, I'll draw it that way as well. All right, so that'll be red x, that'll be red y. Okay? I did a terrible job with my green triangle there. I'm just gonna fix it. Okay, so that is my diagram. Okay, and this red line represents the total displacement, and I would want to find that angle right there. If you drew the triangle the other way, that's totally fine. All right, I'll give you a few more minutes to get ahead of me here. So we want to start out with our blue triangle, okay? And if I want to find blue x, it is the adjacent side to my 8.5 degree angle, right? And I have the hypotenuse, so what trig function am I going to use there? Cos. All right, so I'm going to go. I'm going to go cos of 8.5 degrees times 10 kilometers. Okay. All right, so we got 9.89 kilometers, and that one's west. Okay, to find y, then it's obviously the opposite side, so I would use sine of 8.5, okay, times the hypotenuse, 10. Okay, so we got 1.478 kilometers, and that is south. Then we got to do the green triangle. Okay, so for the green triangle, because they're both drawn kind of the same way, x is again the adjacent side to that 30.5 degree angle. So I'll go cos of 30.5 times now the hypotenuse being 7.5. Whoops, 30.5 now. Okay, so we're looking at that side being 6.462 kilometers west. Okay, and I always write in those directions so that I kind of know which one's got to be positive and which one's got to be negative. And then the last one, sine of 30.5 times 7.5. And it gives me that other side, so 3.807 kilometers south. Okay, so now I've got all the x's and all the y's. Now I can find my resultants, x and y. Since all of the x's go the same way, I just have to do what with the numbers? Add them, right, they're all west. Right, so red x is going to be 9.89 plus 6.462. And again, I want to keep all of my decimals in the calculator for this one. So I've got to scroll up a ways. That one plus that one. Okay, so we're looking at 16.352 kilometers west. And then for our y component, I add the two y's, so that'll be 1.478 plus 3.807. Sorry, I got those numbers. Yeah, 1.47, 3.807. That's the one I want right there. All right, 5.285 kilometers, and that is going to be south. So now I know that this side here is 16.3, and I know that this side here is 5.28. Right, now what can I do? Now I do Pythagorean theorem. Okay, so it's always the same set of steps, right? So I got square root of that one squared plus that one squared. Okay, so my overall displacement, 17.2 kilometers. And my angle, the way I drew this triangle, it's going to be y over x, opposite over adjacent. So that'll be tan to the minus 1 of the 5.28 over 16.3. Guys, you shouldn't hear people packing up while I'm finishing this up.
Wait, what did they say the total was?
17.2. Right there. Okay, and so second tan of the 5.28, that was my opposite side, divided by the 16.35, which was my adjacent side. All right, so that gives me an angle of 17.91 degrees. Right? And now I've got to do significant digits and final answer with directions. So I have 2 significant digits in that question. So we'll be looking at 17 kilometers at 18 degrees south of west, or at 72 degrees west of south. Okay? I would say Tuesday, when we get back, a quiz would look like that question. All right? So plan is this. Tomorrow, we're going to work a little bit more on this. When we come back after the break, we're going to do an activity with maps, take us a couple of classes, and then we're going to finish this stuff up and move on to projectile motion. So expect that when we get back, probably 2 weeks from that Monday will be your unit exam. Okay?